Okay, we're going to look at 24-9, assignment 24, number 9. So it says a 2-kilogram mass. I'm going to write my given and find because that helps me when I'm doing the problem, that I'm not hunting and searching around. So the mass is equal to 2 kilograms. Is swung in a vertical circle at an end of a rope that the length is 1. And that's the radius, so the radius is 1. And you guys have the picture on your sheet, but I'm just going to redraw it so we can conceptualize it. So the velocity, they show us, I didn't read that part, but this is our picture. This is R. And then we have a certain height above the ground like this. The speed at the top, so I'm going to say velocity at the top is 8 meters per second, and the circle is 2 meters above the ground, so h is equal to 2 meters. So now, what do they want us to find? Find A, the speed at the bottom, so VB, B, the tension in the string at the bottom, and C, if the swing breaks, how far will it move horizontally, X. So that's what we want to find. Okay, so just to clarify, I'm going to call this the top, I'm going to call this the bottom, and this is just, I'm not going to call that anything for now. So conservation of energy says the total amount of energy is the same. So what I'm going to do is I'm just going to pretend for now this bottom part, this part doesn't exist, all right? So this is the top and this is the bottom, and I'm not concerned. Remember, in physics, you always have to have a frame of reference. So my frame of reference, this bottom, is what I'm calling base level in this problem right now. This other part doesn't matter right now. Okay, so I'm just using conservation of energy between here and here. Okay, so conservation of energy says, basically in layman's terms, we're going to say that the total energy at the top is equal to the total energy at the bottom. Now in this case, all we're concerned with is potential and kinetic energy. So I'm going to say that the total energy at the top, UT plus KT, is equal to UB plus KB. So this is the potential and the kinetic. Now, I can substitute in what this is. So this is going to be mgHT plus 1/2 mVT squared is equal to mgH bottom plus 1/2 mv bottom squared. Now, as far as getting the points on the AP exam, whenever you're doing anything with conservation of energy, the rubrics is going to say a statement showing conservation of energy is 1 point. Now, honestly, I'm not sure what the rubrics is going to say. So is it going to hurt you? So either this or this is going to give you 1 point. Is it going to hurt you to write both? No. You write both because we don't know exactly what the rubrics is going to look like. If the rubrics looks like this or this, so you write both. First you write it like this, then you write it like this. Most likely the rubrics is going to look like this, but just in case, you just write both. So this shows you know conservation of energy and you get the point. Now, I'm going to say what's 0. Well, first of all, I can cancel the masses. And then if this is my frame of reference, the potential energy is 0 because that height is 0. So this actually is 0. So that disappears. Now what I would do is I like to rearrange the equation to solve for the unknown in terms of the known so I don't make a mistake. So my unknown here is VB. So what I would do is I would just maybe multiply everything by 2. You don't have to do that. But so 2GH, I could just say 2 times GHT plus 1/2 VT squared is equal to VF squared. And then I maybe want to multiply it out and say 2GHT plus 2VT squared is equal to VF. And then because that's squared, I'll take the square root. Now I'll just easily substitute in my values, because when I do this, I don't make a mistake. A lot of times people will forget to do that, take the square root at the end if you leave it like this and plug in your numbers. So that's why when you rearrange the equation to solve for the unknown in terms of unknown, you see this giant radical sign. Are you going to forget to square root at the end? No. Can somebody easily follow your work? Because now, at this point, you're going to get a point for substituting in the values, so the correct value. So 2 times 9.8 times the radius is from here to here, the height, so that's 2 times 1, because it's 2, plus 8 squared. So when you do on your calculator, VS comes out to be 10.16, which is going to be 10.2 meters per second. So all we did was conservation of energy between the top and the bottom. Now for part B, it says determine the tension in the string at the bottom. Okay. Whenever you see the word that refers to a force, tension, tension is a force. And whenever you see the word force, a lot of times you're going to think free body diagram. Now, they don't require you to do a free body diagram, but that's how you do this so you can conceptualize it. So if I'm saying, okay, this is at the bottom, I know my force of weight acts down, which is equal to mg, and my tension is acting up because it's on the bottom. Now the centripetal force is acting towards the center, so that's the one I'm going to use for my sign convention. Centripetal force doesn't go in a free body diagram because that's my net force. So first I'm going to write my sign convention. Up is positive because that's the direction of the centripetal force. So summation of FC is equal to MAC. The net force is the centripetal force, and that's equal to MAC. So again, I'm applying Newton's second law, but I have my centripetal force. So the centripetal force is the mass times the centripetal acceleration. Now I look at my free body diagram. T is up minus the weight is equal to M. Now remember, on AP questions, whatever answer you have for part A, they're going to end up using it in part B. So centripetal acceleration is VB squared over R. So you see how we end up using our answer from part A and part B. Now I want to solve for the tension, so I'm just going to rearrange the equation and say tension is equal to, I'm just going to move my weight to the other side, M VB squared over R plus mg. So now I'm going to substitute in my value. So tension is equal to 2 kilograms times 10.2 meters per second squared over 1 meter plus 2 kilograms times 9.8 meters per second squared. So when I do all that, my tension comes out to be 227.68. So we'll say the tension is 228 newtons. So if this was, again, 3 points, you know, this is going to be a point, this, and then that's a point. If you just like write numbers in a unit, you're not, because if they don't see that you're substituting in the correct values for the variables, you don't get that point for substitution. Because they don't know what you're substituting it in. So you can't just start writing numbers. And then part C says, how far does it land? So now let's look at a picture, because when you draw a picture to help solve something, okay, that's how you conceptualize it. So they gave us this height. We know that the velocity at the bottom is tangent to the curve at that one point and that one point only. And now when it goes off, it's going to be a projectile. So however you want to answer this, you know, if you want to do your x and y given, AX is 0, G is negative 9.8. We know that V naught Y is 0, and V naught X, it's all horizontal. We found in part A is 10.2. And then we know that this Y, the height is 2 meters. So when I want to find X, I know X is equal to V this is actually VBX times T, but we don't know T. So in order to find T, I use these three things, and I know that Y is equal to VBYT plus 1/2 GT squared, but there's no Y component, so that's 0. So Y is 1/2 GT squared. I'm going to rearrange the equation. So 2Y over G square root is equal to T. So 2 times 2 meters over 9.8. So T comes out to be 0.639 seconds. And once I know that T, then I'll substitute it in here. So this is going to be 10.2 meters per second times 0.639. So X is equal to 6.52 meters. So again, I always have to write my basic equation. Then I'm going to substitute in my values and I'm going to solve. So that's 1.2.3 points. 1.2.3 point. And then I get my maximum point. And that's how I get a 5. And a lot of times, whatever answer you have in part A, you're going to use in part B, and then you're going to use in part C. If you think you got this answer wrong, or you're not sure how to do this part, you make up an answer like 4, and then you substitute it in.